This is the quick tutorial on how to do your lab about the shapes of covalent molecules and polarity. You need to have watched the VSPR video, and you need to have watched the one about polarity. VSPR is pronounced VSCPR. Now, we're going to look at different atoms here where they have different colors. So the colors are, for the most part, are going to stay the same. Carbon is still going to be black, hydrogen is still going to be yellow, nitrogen is blue, oxygen is red. However, the halogens, chlorine and bromine, those are going to be the same color. They're going to be purple. Now you're going to have to describe the shapes and draw the Lewis structures of them with their lone pairs, and I'm going to show you them here. You'll have to get this printout. You'll have to write all your answers in, then you'll have to take a picture of it and send it in through your Schoology. Now you have H2, which is hydrogen gas, HBr, H2O, NH3, CH4, HClO, N2, C2H2, CO2, H2CO, and then CH3Cl. When you see a molecule, you will have to draw the electron dot diagram. That is the Lewis structure. You will have to draw a sketch of the model. That's just the ball and stick model. Just draw a circle for an atom and draw a line for a bond. Now the shape of the molecule, you will need to tell me if it's linear, bent, trigonal planar, trigonal pyramidal, or tetrahedral. Now the type of bond, you'll have to, they're all going to be covalent. So tell me if it is polar covalent or non-polar covalent. That's what I'm talking about here. And you'll see that HClO has two spots because we're looking for something between H and Cl, and I'm sorry, between H and O, and then O and Cl. Okay. Again, you'll see another one right here. You have C2H2. You'll need a bond. Tell me between the difference between carbon, and then carbon and hydrogen here. And then here it would be carbon to oxygen, and then carbon to hydrogen. And then here would be carbon to hydrogen, and then carbon to chlorine in this area. Now the molecular polarity is talking about, tell me if it is a polar or non-polar. Now don't just guess. Look at the entire shape of the molecule and look at the electron dot diagram. You can tell that usually if it is symmetrical, it is going to be non-polar. But if there is a lopsidedness of charge, lopsidedness of electrons, then it is going to be polar. Okay, so if it's symmetrical, it's typically non-polar. If it's lopsided, then it is polar. Then something like water, something that has lone pairs on the central atom, well, that one is always going to be polar. Okay, so just a few helpful hints. I'm going to show you what those molecules look like right now. Remember, you have your list here. These are the 5 basic shapes that could be. These should be in your notes. You have linear, bent, trigonal planar, trigonal pyramidal, and tetrahedral. Those are the 5 possible shapes. So now let's take a look at that first one. The first one was hydrogen, and it looks like that. That's hydrogen. Now HBr, not much of a change, but it's going to look like that. Now I suggest this purple one is bromine, so I suggest you put lone pairs on bromine. Then you have H2O right here. The lone pairs are not pictured, but there are lone pairs. There should be lone pairs on oxygen here and here. 2 sets of lone pairs. And now NH3, this guy is going to look like this. So to give you a dimensional shape right here, there should be a set of lone pairs on this one as well, right where my pen is. And now CH4 should look like this. HClO is a peculiar one. Oxygen is the central atom. The red one is oxygen. And then the purple one is chlorine. And then the yellow one is hydrogen. Now don't forget about your lone pairs. Oxygen should have 2 sets of lone pairs, and chlorine should have 3. Next one is going to be nitrogen. Now this is a really cool way to show multiple bonds, is we show these little springs right here. So what kind of shape would that be? You have a triple bond here, and you should have lone pairs on over here and over here. And then C2H2, a very cool one as well. You have a triple bond in the middle. This is an alkyne, and we have a hydrogen here and a hydrogen here. Remember, hydrogen never gets lone pairs, and carbon almost never gets lone pairs. Okay? So you should not be putting lone pairs on that one. CO2. This is CO2. You have 1 carbon and 2 oxygens. You have a double bond here and a double bond here. And note the shape. Don't forget about lone pairs on oxygen. You should have lone pairs here, 2 sets of lone pairs, and 2 sets of lone pairs over here. And then H2CO. Here's carbon in the middle, and you have 2 hydrogens here, and then an oxygen on top. I will rotate that so you can see what it looks like. And then the last one is CH3Cl. Here we are. What type of shape would that be? And then remember, hydrogen never gets lone pairs, so the yellow ones don't get lone pairs. The yellow ones are hydrogen, the black one is carbon, and the purple one is chlorine. Chlorine gets lone pairs though, so make sure he has 3 sets of lone pairs around it. Alright, that will be it for your Shapes Lab. Have a good day.